Okay, this is section 7.2, continuation from yesterday. So day 2. We're going to work a little bit more on reflections, on finding the line of reflection, on actually doing the reflection of a shape over a line of reflection, and figuring out a lot of different things about that line of reflection once we find it. Okay, so just a little bit of review from yesterday. A reflection is a flip over the line of reflection, right? You always need a line of reflection. So I keep saying that because for translations, what you needed is instructions, right? You needed how much to go left, how much to go right, how much to go up, how much to go down. You needed a vector that tells you which way to go. But for reflection, you don't need a vector. What you need is a line for which you need to jump over. You need to flip over that line. That's all you need. If you have that line, then you could create, you could draw the reflection. So for example, you have a couple of pictures here. Here's this first one. The pre-image is right here, and the image is down here, right? Here's the pre-image, here's the image. What happened to the pre-image to get to the image? It got reflected, right? See the reflection right there? You could obviously see that it's a mirror image of it. What is the line of reflection in this case? You could pretty easily figure it out, but if not, you can just count and find the midpoints. That's what we did yesterday. Count the distance from E to E prime, which is 4 units, so the middle must be 2 units, so right there is the midpoint. Do the same thing for this point and this point. That is the midpoint. You connect those two midpoints, and that is your line of reflection. Your line of reflection is the x-axis. If you look at the second picture here, you can just pick these 2 points and see the midpoint is right here, right on the y-axis. If you pick A and A prime, you could see that the midpoint is right here on the y-axis. So the line of reflection is the y-axis. In this one over here, it might not be so obvious to see, but you could still do the same thing. If I connect, let me zoom in here. If I connect this point to this point, like that, then the midpoint would be somewhere around here, right? I could do the same thing to this point and that point. If I connect them together, actually, I'm going to try to draw the line. It's not going to be a straight line, but I'm going to try. If I connect those 2 points, yeah, I try to draw it, and I got a squiggly line, because for some reason my stylus won't draw a straight line right now. So you can kind of tell that the midpoint is right about here. And if I do the same thing for 2 other points, let's say these 2 right here, which again gives me a squiggly line, I can see that the midpoint is somewhere around here. So you can connect those 2 midpoints to create your line of reflection. Okay, and if I do that, this is what my line of reflection looks like. It goes right through the origin, like that. And it hits every single corner of all of these boxes that you guys see. Okay? It's the line y equals x is what it is. Okay, if you reflect your image across your pre-image across that line, it becomes the image over here. Okay, that's what the line of reflection is in this case. Notice that every single time, every single point in the pre-image is the same distance as its image from the line of reflection. And also, if you connect a point, a pre-image to its image, that line that you create, that segment that you create by connecting them together is perpendicular, right, to the line of reflection. Those two are perpendicular right there every single time. Look at A. Draw the image of triangle ABC after a reflection across line L. So there's line L, and we want to reflect it across that line. They already did the first one for us. They did A prime, and notice that the way to do it is really easy. You just count. How far is A from the line of reflection? Well, it looks about 2 units. It's not really because it's diagonally, but I need to go diagonally in order to hit the spot, right? So about 2, so I count the exact same distance on the other side. Even though it's not a straight horizontal or vertical distance, I can still count from corner to corner. See that? From here, from this corner to that corner, from that corner to that corner. Therefore, I do the exact same thing on the other side. Okay? And I could do the same thing for B. Look, B is only 1 away. Okay, 1 diagonal distance. So B prime must be right here at this spot. I'm going to draw B prime right there. there's B prime. I could do the same thing for C, kind of, because it acts a little weird once we get close to it. But look, 1, 2.5 to get to the line of reflection. So here's the half, and then 1, 2. Right here is where C prime should be. Right there. And I connect A to A prime to C prime. I mean A to A prime to B prime to C prime to get my line. And again, my stylus for some reason just does not want to draw straight lines today. So, but I'm going to try fight with it again. Like that, and like that. There you go. There is A prime, B prime, C prime. The next question is, what is the slope of line L? So for that, all we need to do is just count squares. Here's line L. The slope, pick any 2 points on line L. So for example, I'm just gonna label 2 points. Here's 1 point on line L, and here's another point on line L. I just chose those two randomly. What is the slope? Just find the rise and the run. From here to here, the rise is -2. The run is +2. See that? Down 2, right 2. So if the rise is -2 and the run is +2, that means that the slope, the rise is -2, the run is 2, that means that the slope is -1. Next question is, what is the perpendicular slope? We know how to calculate that. Perpendicular slopes are opposite reciprocals of each other. So the opposite of negative is positive, so it's going to be positive, a positive number. And the reciprocal of 1 is 1, right? Because it's 1 over 1. The reciprocal is 1 over 1. So the perpendicular slope is just m equals 1. You can check that by simply looking at the line here connecting A to A prime, or B to B prime, or C to C prime. All of those lines have the same slope, which is 1, right? Up 1 over 1, up 1 over 1, up 1 over 1, and so on. They have the exact same slope because they're all perpendicular to the line of reflection. Okay, you guys try B. Do the exact same thing I just did in the last one. Draw the image after the reflection, then figure out what the slope of line L is, and then what is the perpendicular slope. Okay, go ahead and pause the video right now. Do it on your own, then unpause it to check your answer. Okay, so pause your video now. Okay, so I hope you struggled through that one a little bit. It is a little bit tougher than the ones you've seen. Okay, so let me guide you through it. If you didn't struggle through it and you think you got the correct answer, then this is an opportunity to check your answer, okay? So here, the best way to do this, there's actually a couple of ways to do it. The best way to do it is to just use some kind of paper that you can just fold over and draw the reflection. That's always going to be easier. But you don't want to do that. Well, the best thing to do is to find these two things first. If you can find those two, then you can easily find the reflection. Watch. What's the slope of line L? Well, the slope of line L, in order to find that, I need 2 points. I have 1 point right here. I'm going to use that one. And then I have another point right here. See that? If I use those 2 points, I'm going to label them right now real quick. Here's this one, and then there's this other one. If I use those 2 points, the slope is rise over run. So from here to here, rise is 1, run is 2, right? 1 over 2. The slope is 1 over 2. 1/2. So what is the perpendicular slope then? We know that. It's the opposite reciprocal, correct? So -2. So the slope of the line of reflection is 1/2. The slope that is perpendicular to it is -2. Now in fraction form is -2 over 1, correct? That's what's going to help me find the reflection, because I'm going to use this slope to find what happens to each one of these points, okay? Because I know that B and B prime, wherever B prime is, I don't know where it is, but B and B prime, if I connect them together, their slope is going to be this, -2 over 1, which is the opposite reciprocal of line L. So I'm basically going to use this and guide myself to figure out where B prime is. Watch. Look at B. Actually, let's do A first because it's much closer and easier. Look at A. I'm going to use this to guide myself. I'm going to go down 2 to the right 1 to figure out where A prime is. Down 2 over 1. That's not A, right? That's just the line of reflection. It should land you on the line of reflection, okay? But keep doing that. Down 2 over 1, okay? I do it once on this side, I do it once on this side. So right here, where I just landed, down 2 over 1, down 2 over 1, this is A prime, right? I did my slope once on this side, I do it again once on this side. That's A prime right there. I'm going to label it right here. And I need to erase these because I don't need them. All I did was use them for the slope. I'm going to do the same thing for B. Look, down 2 over 1. Same slope, right? Because B and B prime are going to be connected by the same slope. Down 2 over 1. Down 2 over 1. I'm at the line of reflection, and I did it exactly twice. Do it twice again. Down 2 over 1. Down 2 over 1. Right here is where B prime lands. What happened to C? Well, since C is on the line of reflection, you reflect it and it lands in the exact same spot. It does not move. There you go. Those are your 3 points. Connect them together and you got yourself your figure. Okay, I'm going to try to connect them right now, but again, my stylus is being weird. I can't for some reason make any straight lines, but let's try. There you go. Not straight at all. That is the worst triangle I've ever drawn. But you guys can probably do better on your paper. Okay, part C is much easier. You guys can probably handle that. So go ahead and do that one on your own. Take a few minutes, finish it on your own, then come back and check your answer. Okay, here it is. This one should have been easy. This one is a perfect line of reflection because it goes through every single square here. See, this is y equals negative x. That's what it is. So it's real easy to find the reflection. You just count how many squares away. Even if you have to go diagonally, it is 1, so 1. 1.5, so 1.5. 3, so 3. Okay, and there's your image. Okay, this is A prime, B prime, C prime. Once again, I'll let you guys work on this one. You can handle this one on your own. It is much easier than the previous ones. Actually, no, it's just as easy as part C. So go ahead and do it on your own. Pause the video. Come back to check your answer. Okay, here you go. There's your answer. All I did was just count. This one is like half a unit away, so half a unit away, right at that point right there. B is 2 units away. It's not really 2 units. I'm counting diagonally, so it's actually a different distance. But I'm 2 diagonal units away, so 2 diagonal units away. And C is 1, 2, 3, 4 diagonal units away, so 1, 2, 3, 4 diagonal units away. That's C prime right there. A prime, B prime, C prime. Connect them and you got your triangle. Alright, we're going to do E together. It says use the grid below to answer the following questions. Number 1, which figure is a reflection of figure A? Okay, so here's figure A over the y-axis. Here's the y-axis. So think about this carefully. Here's figure A. Here's the y-axis. Which figure is the reflection of A over the y-axis? So we take A and jump over the y-axis. Where does it land? C, right? That should be pretty obvious to see. If not, you can count squares. Look, 1, 2, 3, 4. A is, this point right here is 4 units away from the y-axis. 1, 2, 3, 4. This point right here is 4 units away from the y-axis. And that's true for every single vertex of this triangle. So it's C. Figure C. Alright, next one. Which 2 figures have x equals negative 3 as their line of reflection? Which 2 figures have x equals negative 3 as their line of reflection? To help me out with that, I'm going to draw x equals negative 3. Then I will erase it for the next question because I won't need it. But x equals negative 3, remember what that means. It means on the x-axis, find negative 3 right here. And then draw a vertical line. Here's x equals negative 3. That's x equals negative 3 right there. So the question is, which 2 figures have this as the line of reflection. You see it? It's not A and B, right? B is too far away. D doesn't have a reflection on this side. E and F. You see that? E and F are a perfect reflection over that line. E and F is your answer. Alright, next question. It says, which figure is the reflection of figure A over the line y equals x? So first of all, let me erase this line that I don't need anymore. Which figure is the reflection of figure A, here's figure A, over the line y equals x? The line y equals x is a perfect diagonal line that passes through the origin. Okay, let's try to draw it real quick. Here's the line y equals x. There's a line y equals x. Which figure is a reflection of figure A over this line? So we need to take A and make it jump over this line. Where does it land? Not G, right? Look, that's not a reflection. H. H is your correct answer. Okay, number 4. What is the equation of the line of reflection? You know what, before I finish reading that, let's erase this. What is the equation of the line of reflection for figures G and H? Here's G and H. They are a reflection of each other. The question is, what's the line of reflection for those two? Okay, so what you need to do is find the middle point, the midpoint between each one of their vertices. The midpoint between these two is right here in between them. 3 and let's see, if this is -4 and this is -5, then in the middle is going to be -4.5, right? 3, -4.5. Let me write that down. 3, -4.5 is one of the midpoints. I could do the same thing with the other midpoints. Between this point and this point, it's 6, -4 and 6, -5. The middle is going to be right there between -4 and -5. So 6, -4.5. In fact, if I do the same thing for these 2 points, I'm going to get the same y value, which is -4.5. That pretty much tells you that the equation of the line of reflection is this y value that they all have in common. It's going to be y equals -4.5. It's a horizontal line that passes through -4.5. All right, finally, number 5. Which figures are not reflections of figure A? Name all. Here's figure A, and the question is, which are not reflections of figure A? So let's just go through each one to see if they could be reflections. Here's A, here's B. Could B be a reflection of A? Yeah, do you see it? It is a reflection. The line of symmetry would be right about here. So what about C? Yes, we already actually talked about C. C is a reflection over the y-axis, right? This is the line of reflection right here. What about D? Is there a way to reflect A and make it be land on D? Not possible, right? Remember, reflection is a flip. This one's not flipped at all. It's facing the exact same direction. It's a translation of it, right? It moved to the right and down, but it's not a reflection. So D is the first one we found. Not a reflection. All right, let's keep going. What about E? Yeah, E is a reflection, right? Here's your line of reflection right here, the x-axis. What about F? Could I reflect A and make it land on F? You can try as hard as you want, but it's not going to work. Okay, this is actually a rotation of A, right? It turned to land on that one. There's no way you could reflect it. Even if you draw a diagonal line like this, you won't be able to reflect it and make it land exactly on that. So no. What about G? Also no, right? It's another one of those turns. It's a turn to make it land on that one, not a reflection. What about H? Yeah, we already talked about H. It's a reflection of A over the line y equals x. Your line of reflection goes something like this, and it lands on H. Okay. So H is yes. So what are the ones that we said no to? We said no to D. We said no to F, and I never wrote it down. And we said no to G. Everything else is a reflection of A. Okay, these are the last two examples. After this, you're on your own for the homework. So I'll do F and then you guys will do G, okay? F, reflect the figure with the given vertices across the x-axis. Reflect the figure with the given vertices across the x-axis. So what I'm going to do first is plot all of these points on my graph and then reflect them afterwards. So here's P is negative 2, 3, negative 2, 3, right there. Q is 4, 3, right there. R is negative 1, 0, right there. And S is negative 4, 1, right there. So my figure, again with my squiggly lines because my stylus can't draw a straight line. Hey, that one came out pretty nice. That one too. Looks something like that, kind of like a kite. And the question is to reflect it across the x-axis. So let me just highlight the x-axis real quick so we can see it clearly, although you should be able to see it. I missed, but that's where the x-axis is. And what we want to do is reflect that figure across it. So that's actually pretty simple, just count squares, right? So this point is 3 units away, so 3 units away, right about here. This point is right on the x-axis, so it stays there. This is 1 unit away, so 1 unit away over here. And this one's 3 units, 3 units. So it's going to land here, 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 and here. Okay, let me plot those points real quick. This one's going to be 1 unit away, so right here. This one's going to stay right on the x-axis. This one's going to be 3 units away, right there. And the last one on the right side over here is going to land 3 units away again, so right there. We can connect those to make our shape. And there you go. That is the figure reflected across the x-axis. Okay, your turn. G is for you. Reflect the figure with the given vertices across the line y equals x. So I'll just give you a quick hint before you guys start. The line y equals x is a diagonal line that passes right through the origin, positive slope. So graph that first, plot the points, and then reflect. Go for it on your own. Pause the video right now and then come back once you're ready to check your answer. Okay, so here you go. We reflect the figure with the given vertices across the line y equals x. I haven't drawn the reflected figure because I don't want to confuse you guys with too many lines. But just to guide you guys along, this is the original, the pre-image, right? Negative 1, 1, 3, 2, 4, negative 1, and negative 1, negative 3. The red squiggly line here is y equals x, right? It passes through the origin and the slope is 1, so it goes up 1 over 1, up 1 over 1, up 1 over 1, and so on. That is y equals x. And the goal is to reflect this black figure that I drew over this red line. Okay, so what I did already is I plotted those points, and this is how I did it. I basically counted the distance from each of the vertices of my original pre-image and reflected it over, flipped it over. So this one lands on that side. This one lands all the way over there. This one lands right there. But this one goes the other direction, right? Since it's already on this side of the red line, it's going to land on the other side of the red line. So yes, they do overlap each other in that form. And I'm going to connect them to see what it looks like. One goes up that way. That one goes up that way. That one goes that way. And then that one goes, that's way off. That one, again, way off. That way. And there's your line, your reflected image. Okay, so at this point you're on your own for the homework. Go ahead and do that on a separate piece of paper like you usually do. If you need extra help, then you can always go back to the examples and watch them again. Okay, see you guys tomorrow.